Good morning, girls. We will continue the same chapter, that is magnetic effect of electric current. And today I will take up the topic electric generator. Now, children, in the previous videos I have explained you what is electromagnetic induction. Now, why I explained you? Because electric generator is actually based on the principle of electromagnetic induction. If you have not seen those videos, children, please see those videos and then you will be able to understand what is a generator, right? Now, firstly, we have to understand what is a generator. Now, generator is a device which converts mechanical energy into electrical energy, right? I repeat, what is a generator? It is a device which converts mechanical energy into electrical energy. Number two, it works on the principle of electromagnetic induction, right? And the third point is it is exactly opposite of what we studied in electric motor, means the principle of generator is opposite to the principle of electric motor. If we will compare those two devices, we will be able to understand what are the differences that we will discuss later on. Now, what is EMI? That is, what is electromagnetic induction? When any conductor is placed in a magnetic field, or when any conductor is subjected in a magnetic field, the current is induced in that conductor, and this phenomenon is called electromagnetic induction, which I have explained you in my previous video. Okay, now the generator works on the principle of electromagnetic induction. Now, as you can see the diagram over here, that there are two poles, north and south. There is a coil over here, ABCD, then ABCD, yes. Over here, then as you can see over here, that there are two rings, and I've named these rings as R1 and R2, and these rings are attached to the brushes. Now, when you will see this diagram, you may remember that the construction of this is similar to what is in the electric motor. Now, the parts are almost similar, but there is only one difference, and that difference is that in the electric motor there were two split rings, means they were half rings, but here we have two complete rings, and these rings we name them as slip rings, and in the previous one we had named it as what? Split rings. They were split rings, and this is a slip ring. Now, then you can see that there is a G, that is a galvanometer, and this galvanometer will show the deflection because the current will start flowing in the coil, and we will now understand how the working of this generator take place. Now, if we assume that this is our coil, this is a coil, a rectangular coil, which is placed between the two magnetic poles, that is north and south, and the direction of the magnetic field is always from north to the south, right? Now, as I told you that electric generator converts mechanical energy into electrical energy, so therefore we have to first rotate the coil. When the coil will rotate, the current will be induced in the coil, right? And therefore we can say that the mechanical energy changes to electrical energy. Now, we can rotate with the coil either with the help of water, either with the help of wind. That depends on where this generator is being used. Now, when the coil rotates, now as I told you that here ABCD is a coil. So if we assume that this is AB and this is a CD part of the coil, and when we start rotating whichever direction, suppose we start the direction in such a way that AB goes up and CD comes down. Okay, now remember that ABCD is a rectangular coil placed between the north and the south poles of the magnet, and the rotation of the coil starts in such a way that AB goes up and CD comes down. When the half rotation is complete, what happens? CD will go up and AB will come down. So therefore this type of cycle will go on, right? And this coil will keep on rotating in between the magnetic field, and the current will be induced in the coil, right? And therefore mechanical energy will change into electrical energy. But if we have to understand the direction of the current at AB and CD, we have to apply which rule? We have to apply the Fleming's right hand rule. Okay. Now, beginning with AB. Now, beginning with AB, as I told you that when AB goes up, now when we stretch the three fingers of our right hand, right, this forefinger, thumb and the center finger, when the direction of the motion of the conductor is upwards, I am only taking the AB part of the coil. So when the motion is upwards, we can understand it by, this is the direction of the magnetic field, and which is shown here from north to south, and the coil is, the AB side is coming up, that is the motion of the conductor is up. This is the direction of the magnetic field, and therefore the center finger will show you the direction of the current, and therefore it will be inward, or here we can show that it is upward. Okay, on the board we have to show it in the upward direction. Then CD. This CD, because the coil is rotating, AB is up, CD is down, right? The motion is like this. So again, when we apply the right hand rule on this part, that is the CD part of the coil, then if we again stretch the three fingers, the motion is not upward, but it is downward. Okay. So when the motion is downward, this will show the direction of the what? Magnetic field. So same way, here is the direction of magnetic field along, means in reference to this diagram. This is the motion of the conductor downward, and this center finger is showing the direction of the current, and therefore it is in the opposite direction to what we had done in the previous one. So therefore the direction will be down. Right? So you can understand the rotation of the coil once again. This way the rotation of the coil take place, and AB goes up, CD goes down, then CD goes up and AB goes down. So this way the rotation goes on. Now when we see this part, that is from A to B, C to D, the current starts flowing from A, goes to B, right? Then it is going to C, then it is going to D. Now after D, what is happening? The current is entering R2. What is R2? Ring 2. Then it goes to B2. Yes, the current starts flowing from here. Then the galvanometer will show the deflection because the current is induced in the coil, and then it, after B2, it enters B1, enters R1, and then go back to the coil, that is ABCD. So this is the direction of the current in the first half of the rotation, when the AB goes up, CD goes down, and the rotation continues. But what happens in the second part or the second half of the rotation? The direction of the current or the direction of the induced current changes. It is not A, B, C, D, but it is the reverse of it, and that will be from D to C to B to A, right? D to C to B to A. Then the current goes to R1. What is R1? R1 is ring 1. Then after R1 it will go to B1. Then it will go to B2. Then it will go to R2, and then back to D, C, B, A. Now this is happening in the first half, A, B, C, D, and this is happening in the second half. So as you can see that in the first half, the direction of the current was from A to B to C to D and so on. And in the second half, it was from D, C, B, A. So therefore, in this rotation, what happens? Alternately, the direction of the current keeps on changing. And therefore, we can say that the current which is induced in this coil is called alternating current. Now, what is alternating current? Alternating current is a current which changes its direction periodically, right? And there is one more type of current which is a direct current. Direct current is a current which flows only in one direction. But here, since the direction of the current is changing, we can say that this generator is an AC generator, right? Because the current is constantly changing its direction, and thus the current which is induced in the coil is called a alternating current. And therefore I told you what is alternating current. It is the current which changes its direction alternately. Okay, so now what you will do today, you will draw this figure. You will first write what is a generator, right? What is the working principle of generator, and the diagram you will draw along with the working. I will give you the notes on this topic, right? You can write in your notebook and you will refer to your book. Now in my next video, I will also discuss with you what is a DC generator, right? And also what are the differences between the electric motor and the electric generator, right? So today you study all this and the working principle. What are the parts? What are the main parts of the electric generator? And what is the main part which differs from the electric motor? That is, in the previous that in that device we use the split rings, but which are the halves of the two rings. Here we use the two complete rings, which we call them as slip rings. So almost the parts are same, only one difference is there. And then how does the current changes its direction, which rule we apply, all this you can write in your notebook, and then we will continue with this topic in the next video. Okay, thank you, have a nice day.